Good morning, everyone, and thank you, Nick. My name is Daniel Trinder, and I'm a senior advisor at Afore Consulting. And I'm joined this morning by Gary Kazantsev. Gary's the head of Quant Tech Strategy at Bloomberg. Gary, welcome to the annual FinTech conference.
Thank you for having me.
So, Gary, let me start by saying we often hear a lot about the benefits of AI and machine learning, especially in those industries that are dependent on technology. Now, you've been working in this space in the sort of the financial services area for 15 years, 1.5 decades. And I wanted to start by asking you, what have been the big changes during this time, both in terms of technological advancements, but also the impact that has had on business models?
Thank you, Daniel. That's a great question. There have been a great deal of change. When I started in this industry around 2007, the world was really quite a different place, certainly in terms of technology. Right? In artificial intelligence and machine learning, most of what we hear about nowadays is deep learning, ever larger models based on deep neural networks. These things are very expensive computationally to build. Right? 15 years ago, that was not really the focus. Right? The software, the hardware, the state of the open source world, it was very, very different. So if you wanted to build something like a deep learning model, which was possible, the theory was there, it was all basically bespoke. You had to write everything from scratch. And I think that's generally more true around technology and software technology in particular, for things which now are considered fairly, I guess, mundane or kind of taken for granted. So things like being able to do distributed computing, to do parameter searches for statistical models, all of that had to be orchestrated basically on a bespoke basis 15 years ago. Now we have a great deal of generic open source technology. The barrier to entry to build a technological system involving machine learning or some sort of artificial intelligence method is vastly lower. So back then it was only possible for really companies which are technology companies at its core, right, that have a strong engineering culture and a lot of engineering resources. Now, for the amount of money that you have in your pocket, you can basically rent a supercomputer on AWS and build things that were basically infeasible 10 years ago. So the world has changed a great deal. Now, as far as impact goes, the impact has been that majority of the financial industry at this point is trying to incorporate this novel technology into their business processes. So every client that I speak to, and I speak to a lot of them, generally speaking, is either building a data science team or some sort of technology capacity, or has already built it and is trying to scale it, and is trying to apply these methods to basically every part of their business. Now, there are people who have been there with us from the beginning. So this is not new in any way, right? It's just that what has only been available to select few 15 years ago is now available much more broadly. So, and people are applying this, just for the sake of example, to automation, right? And to automating business processes having to do, for instance, with information extraction, reducing the kind of tedium, right? And the cognitive load, right? Of, copy pasting, data from PDF documents into forms, right? That's much better done by a machine. But to things, that have to do with actual operation of their trading workflow, like execution or venue routing and things like that. So this is all very much amenable to automation using machine learning models, and the outcomes are frequently quite a bit better than what you would be previously able to achieve using kind of human effort.
Mm-hmm, mm-hmm. And what is that? So that automation, there's clearly efficiency gains here for the firms. But has there been a lot of blurring of the business models at all through your clients?
Certainly, it has at least started breaking down barriers between asset classes. So things that had been pioneered, for instance, in the equity industry, in terms of quantitative models, right, and more recently, machine learning models are now being exported to other parts of the industry, to fixed income, right, to derivatives and so on. So in that sense, definitely it's true. Um, in some cases, however, it has gone in an opposite direction, right, because to build a machine learning system is a still fairly technologically advanced thing to do. So you end up with kind of a more of a, I guess, spread, right, between firms in terms of their capabilities. In that sense, it has built new barriers. Right.
Yes, I can see that. Yeah. Then how would you characterize the benefits in terms of AI, ML, the other technologies you mentioned to the financial sector industry generally, and ultimately what matters to their clients?
Right. So this is a little bit more complicated to answer because the answer is it's actually quite diverse depending on the specific part of the industry that a particular client is in, right? Whether they're a buy side, organization or sell side organization, if they're a hedge fund or an insurance company or a sovereign wealth fund, right? All of these actors have a very different risk profile, right? And therefore, very different due diligence process, right? For introduction of new technology of any kind, right? And furthermore, also kind of in terms of their really capital management model. So the benefits are going to be quite different. So if you are dealing with, say, a hedge fund, right, whose risk profile is quite lax in many cases, right? So they basically can do whatever they want. They're only dealing with qualified investors, right? So I know a couple of organizations around the world, and the number is growing, where their whole trading workflow, literally from selecting the tradable universe all the way to execution, right? Every part of that is basically a machine learning model. So, and they train the whole thing basically start to finish, right, as an ensemble. So that was very difficult, if at all possible, to do 10 years ago. But now, I know funds that do this, and I know specific desks within other organizations that do this. If you are, say, a market maker or sell-side organization, then, and in many other cases, I know, and this is a matter of public record, that people have been able to improve their quality of execution considerably, and by using things like reinforcement learning and, methods out of machine learning world. So that's a very different type of kind of game. All of the things that we hear about alternative data, unstructured data, using these kind of more unusual data sources to construct factors for, trading strategy construction, for factor construction, it would have been impossible without, say, natural language understanding technology, which is based on machine learning, right? And more generally, without automation, because in many cases, the data sets in question are enormous. You're talking about credit card receipts data, right? Or all the news that are published in the world, right, on a given day, or, geolocation data for foot traffic and whatnot. So these things are hundreds of terabytes in size, right? How would you even touch the thing? And then you kind of without this type of technology. And in particular, this alternative data angle, that matters more and more to our clients, right? In many cases, it is becoming basically table stakes, right? Because that data allows you, if used correctly, to build kind of an alternative view into company fundamentals, which is decorrelated from, other variables which are more traditional.
Okay. If I just change tact slightly now and move away from the benefits but the risks, and I think the reason for my doing that is that many of the people listening to us now are going to be policymakers or regulators on, on one hand, the benefits that you've described, they will want the industry and clients across the EU to reap those benefits from the use of technology and data, etc. But they also need to think about risks. That's their job. And so what type of risks can exist through deploying, say, AI and ML?
That's an excellent question, and I'm glad you're asking about, because this, I think, is underappreciated quite broadly. So the risks of any novel technology, right, are numerous, right? And in the case specifically of machine learning and AI, I think there are really several different, qualitatively different types of risks, right? So there are risks of the technology itself, there are risks around deployment and management, and then there are risks of impact of these kinds of models, right, on market operation, or more broadly on society, right? And we could spend hours talking about, these things, and in fact, people have. So fundamentally, right, if you think about the kind of organizing principle of a machine learning system, right, it's more complicated than your traditional software development, because you're building the thing essentially bottom up from data. So, if your data encodes biases, right, and your model is opaque, right, you might build something that will be flawed, right, and will encode biases which are at best inconvenient to you. So, and there have been many, many cases of this kind of thing coming up, right, major embarrassments for various technology providers, right, in the market. In the financial services industry, that means that your deep learning model that outputs trades might fail disastrously, right? And you would not know why. So this is where the whole field of explainable AI comes in, right? And this is why this is something that I have spent at this point many years working in that specific field of machine learning research. How do we build the models which give you state-of-the-art performance, which at the same time are at least intelligible, right? That you can communicate appropriately to your, management, or to your compliance, or to your risk officer, and so on. So that's one class of risks, right? And we can talk at length about the ways to mitigate these risks and how to kind of go about building models which give you kind of not the best of both worlds, but at least gives you some appropriate compromise, right? Then once you have built the thing, there are purely operational risks, right? So you want your model and your software system to be debuggable, right? You want to understand what it's doing, and if it is outputting an error of some sort, how do you, again, understand why it's happening? How do you fix it? So there is data, then there is code that transforms the data into some sort of mathematical object which is appropriate as an input to a machine learning library. Then there is the library itself, right? Then there is the overall kind of container or software system that embodies all of these things and is able to actually run the thing in production and answer requests and so on. So now suddenly you have multiple artifacts, multiple physical artifacts that you have to manage, right, and keep in sync and version correctly, and kind of keep them all organized in a way that you don't get a different version of this component, right? Where, for instance, your feature generation code changes slightly in a subtle way, and suddenly the input into your machine learning model is basically garbage. Right. So from just an operational perspective, from deployment kind of and debugging perspective, this is more complicated, right? More moving parts, more risks, right? So there is nothing new about that. Right. These at least are manageable, and we're getting better and better at it, right? So, but you do need to be like and play like a technology organization, right? So like you need to understand how to manage software systems, right? How to manage distributed systems, and so on. And then there is a question of impact, of course, right? And this is potentially a very weighty question. So again, it's a question of your risk profile and the type of compliance requirements that you have, right? So, we have things like GDPR and, CCPA, right, which are, I think, a noble attempt, right, at addressing the problem, right? But I think there is more nuance to this depending on the kind of field of application. Let's put it that way, right? So if we are dealing with things like, loans, right, or mortgage insurance and things like that, where we're making decisions that might impact somebody's livelihood in a very profound way, right, then, one set of, I think, interventions is required. If you are, again, a fund, right, which is dealing with qualified investors, right, and which is, advertises in a very transparent way the risks that might be accordant, right, to the strategies to the clients, right, then probably a different set of interventions is required. The impacts obviously are also quite different, right? In one case, somebody might, I don't know. We are applying these methods now, for instance, in the United States in criminology to predict people's propensity to recidivism, right? Well, if that model says somebody should go to jail, I really hope that some human being looks at it and at the output. Similarly, if that model says that you have cancer, I really would hope to get a second opinion, right? Right. Whereas if we construct some sort of index, right, and on the basis of that index, I lose $10,000, right? That's a very different sort of risk. Now, it could be also a very impactful event, right? But it's not the same kind of thing as, life and death in, at least for majority of cases. So, kind of, and people, this is not new, right? So, for many years, right, for these types of credit lending applications, right, there are laws, certainly in the United States, that require you to be able to provide human intelligible explanation, right? And that constrains the space of models that you can use in a very strict way, right? So you end up with models which look like trees, basically, that you can translate into, if and else statements effectively. Right. Whereas if you're dealing with, say, processing unstructured data, right, and your model is some part of a deep pipeline, right, and your machine learning model does, I don't know, word segmentation for Chinese, for the sake of argument, and you're processing, 1 million documents a day, right? If it makes a mistake, does anybody really care downstream? Right? Fine. One sentence in one document is going to be classified incorrectly, right? Because you segmented the words wrong, right? So, as you can see, this is something that we have thought about quite a bit.
Yes.
There is no simple answer, right? So I think it's something that requires careful due diligence on a case-by-case basis, right? And somebody needs to be able to do kind of system-level thinking, right, about the risks that you might encounter. In some cases, this model, for example, might affect the actual process that generates data that goes into that model as an input, particularly in market. In the market scenario, this is quite possible, right? So then you might have a loop, right? And we see the outcome of this sort of thing. So there are these entertaining cases, right, where people doing algorithmic pricing on Amazon, you end up with two machines competing against each other, right? Each incrementing the previous price, and you end up with something suddenly, being priced at $200 million or something like that, right? So,
yeah.
Well, in the Amazon's case, this is not really that.
So how would you categorize? So how would you categorize the sort of the mitigating actions that need to be thought through for potential risks.
Right. Again, as I have alluded to, the types of risks are many. Right?
Varied.
So I think
yeah.
there are many, I think, different mitigation strategies, right, that will be required. And this is why I mentioned kind of system level thinking. Right. So you need, in some cases, to consider your domain of application from a game theory standpoint, right? And kind of see if, you kind of, if you might end up in inconvenient equilibrium or something like that, or if you are going to generate some sort of runaway process, right? So that's a fairly sophisticated way to think about the world, right? So, and you need people who are able to do that. And you need those people, right? Technologists, data scientists, statisticians, mathematicians, software engineers, people kind of who live and breathe this sort of thing. You need them to be able to bridge the gap between the technology part of the world and the policy part of the world, to at least communicate the risks and the possible mitigation strategies in a way that is, again, intelligible to people. Right, and I don't think we have enough of those people, right? So we need to educate people in this way, right? So not just for technology, but for communication. And I think we need more kind of policy industry and policy academia industry collaborations, right, to reason through the impacts, right, and possible mitigation strategies, right? So what do you focus on first, right? What is the possible space of strategies so that you do not stifle innovation, but at the same time, right, end up with kind of guardrails around the implementation of this technology that do not, cause a market crash or something like that. So I think those would be the things that I would emphasize.
Okay, I mean the whole space in which you've you specialised for many years. Is still evolving incredibly quickly, and it must be a challenge for you
Absolutely.
to keep up to date with what's happening. And if it's a challenge for you, it's even more so for policymakers. And I think what you're saying is there's no clear formula for how people stay on top of developments. But I wonder if there's anything that you do, and some of the people that you work intensely with, that that enables you to understand developments that some of that may then spill over to policymakers and how they might start to think about AI and ML across financial services. So I just wondered, I'm not saying you've got the the perfect formula. What works for you is not going to work for anyone else. But anything you think would be useful for the policymakers listening to us.
Right. So yes, it is indeed a challenge, and I can actually characterize that challenge in a quantitative way. So I run a conference with Columbia University, which is called Machine Learning in Finance. It was in its 7th year last year. So, and at the inception of that conference, it was 2015 or 2014 when we started talking about it. It was actually quite a challenge to find enough speakers and enough material to fill a day. Whereas when I was preparing for the conference last year, I had to read 1,300 abstracts, right, to focus in on, somewhere around 50 different papers, right, of which I had to choose 8. So the amount of work in this area had exploded, right, and it continues to grow kind of along, a curve which certainly looks exponential. So, I can characterize it in another way. Like I said previously, right, what I do research in is interpretability of machine learning models. So there is one particular paper that is kind of cornerstone in a way, right, of that particular direction, right, in the field. And when I looked at it I think it was 2 years ago, it already had something like 1,700 citations, which is quite a lot.
Yeah, it is.
And then I looked at it early, and then I looked at it in the fall of last year, and it had 6,300 citations. And
Wow.
so the difference is several thousand, right, in a couple of years, which means basically that it's like a dozen papers a day citing this one paper in one part of a field. So, which is all a long way of saying that keeping up with this field at this point is pretty much a full-time job, right? You can spend basically all your time reading. And I, am in a way fortunate in the sense that keeping up with it is part of my job, right? So I do this routinely. So how does someone else kind of keep on top of this? I think, again, this comes to kind of communication, right? And having appropriate venues which will serve kind of as executive summary of the recent developments. And in a way, this conference that I ran is one of those things, right? There are other venues, right? Academic and industry venues. So certainly I would encourage people, particularly policymakers, to avail themselves, right, of those opportunities, right? And kind of be able to, find out who are the people working in this area, right? And listen to them, and then pick the ones that they think are, communicating on the right level, right? And engage with them, again, in the form of partnership that I described earlier. So that would be one strategy. I think there is more to do there, certainly. I think we could all be well served by, some sort of a, annual report, and, I'm reminded of the IPCC report, for instance, right? So where an enormous amount of work and, material goes into it, but ultimately there is a summary for policymakers, which is only about 20 pages long, right? Which gives you kind of the highlights, right? And then references to references and so on.
Yeah.
So I think kind of that's a plausible way to communicate a large and complex issue. So I think that might be something like, if I could wave a magic wand, right, that would be the thing that I would probably orchestrate.
Mm-hmm.
Right.
Okay. Yeah. Well, thank you, Gary. I think that's
sense?
probably, it makes perfect sense. But particularly in your sphere, but I think it applies to other areas as well, more generally, in finance. But the sheer speed at which things are moving, totally agree with you, and I think that's my big takeaway. It's been a pleasure listening to you. The more you spoke, the more actually I realised I didn't know or didn't understand myself, and I'm sure that's the same for those listening to us. So thank you very much, Gary. We're going to take a very short coffee break now, and we'll be back at 11:15 when I'll be chairing the panel on central bank digital currencies and the digital euro. Thanks, Gary.
Thank you, Daniel.